taken care by me. Keep in mind that you can spell groin in two different ways. Can be spelled with the Y or with the I. I think in my lectures I have a mixed spelling, but they are both correct. One of the two is American English and the other is UK English. I don't remember which one. Now let's talk about replenishment. Replenishment is an interesting option, and it's interesting because, you know, it looks natural. It looks like a natural way of establishing the shape of a beach. And there is, of course, there are some inconvenience. The inconvenience is that you can easily understand. If you have an erosion problem in a beach, you don't solve the erosion problem if you replenish the beach. You just postpone your problem. It's a temporary solution. And this is why sometimes replenishment is coupled with structures. Because you want to avoid to have to replenish again the beach in 5 years, like, let's say. Also, a relevant problem of replenishment is that, you know, it's not so natural as one can imagine, because it's not easy to find the same sand as the natural one. Because usually you can't go to another beach and take the sand, you can't go to the neighboring beach and take the sand from there. You have to bring new sand, but the new sand has a different color, typically. So sometimes you can really see that there is something that is not natural. So one has to take care about the type of sand, and also there are, in the past, it was suggested, and it's still suggested today, to replenish beaches with a sand with a higher diameter, a more coarse sand, for obvious reasons, because you want to limit the future erosion. But in this case, you know, the impact of the new sand is really significant, because people don't really like, some people like the very fine sand, which is more prone to erosion. And if you bring there gravel, for instance, you know, people are not very happy about that. So we have to take care of the color of the sand, the type of sand, the diameter, and we don't have to exaggerate with the increased diameter, because otherwise it depends, of course, on the use of the beach. But if we go with replenishment instead of building a structure, usually the reason is that we are keen on stimulating tourism, and if we want to stimulate tourism, you know, particular care should be paid to finding the good sand. So, in this case, you see replenishment coupled with groins. They can be submerged. Even groin, as backwater, can be submerged. Also, groins can be permeable. Permeable means with holes. Sometimes groins are made by woody structures with holes, with windows, because to limit the impact, the visual impact, and the impact on the erosion and accretion of beaches. And again, they can be submerged to limit the impact. In this case, we have a protecting bar, which means an artificial bar. The bar is another important protection, of course, for avoiding that the sediment are brought far away into the sea. And the protecting bar is, of course, submerged, because otherwise it wouldn't be a bar, with a higher submergence with respect to submerged breakwaters. So I mentioned to you that when we talk about submergence of breakwaters, it's the order of magnitude is ½ meter. When we talk about a submerged bar, the order of magnitude is 1.5 meters of submergence, or 2 meters. And the protected bar can be made by boulders, for instance. And in this case, you have groins also, so a bar and groins protecting the replenishment. So you build a kind of artificial beach, protected, confined by groins and confined seawards by a bar, artificial bar. In this case, you have the same solution with signals. Of course, for the same reasons that I outlined before. And this is a detail of the same solution with groins of decreasing length in order to induce a smooth transition between the natural situation and the new situations. Now, this is basically the kind of overview that I wanted to give to you on the structures. I will provide later also an overview on natural solutions, green solutions like vegetation. And let me close this overview with a little bit of reflection on what is more advisable. And at the beginning of our, keep in mind that beach protection and restoration became worldwide in the 60s of the past century. So it was about 50 years ago, 50, 60 years ago. And before that, coastal engineering didn't exist. Coastal engineering is a relatively new discipline. And before that, there was harbor engineering in order to design structures for harbors, etc. But beaches became important when tourism became important and environmental concerns gained the attention of the public. And this dates back to about, as I said, 60 years ago. At the beginning, when it was perceived that beaches were exposed to erosion for the increasing urbanization, increasing human impact, increasing withdrawal of sand from rivers. At the beginning, I guess that even people needed a lot of sand to build the concrete and to make the concrete, and I think they went also in the beaches probably. Now you know that it's strictly forbidden to remove sand from a beach. In some places you have to be very careful because they really look after you. When you leave the beach, they look after you. In some places they ask you to clean the shoes because they are very protected. But these are measures that are relatively new. So at the beginning, when they realized that beaches were exposed, they started with infrastructures. So there was a proliferation of groins, breakwaters, and some of them with heavy impact. And then people realized that the impact was indeed significant. So today, and starting from about 1980, 1990, there was an increasing sensitivity to infrastructures, to human impact, and therefore also there was the green politics that was born, which gave an important contribution to environmental sensitivity. And therefore, starting from 1980, 1990, there was a proliferation of solutions that tried to avoid the use of infrastructures. So beach replenishment, green solutions, etc. And today we are, I would say, just still close to the crest of this wave. So the wave of green solution is still close to its crest, but it's starting to move down a little bit because we realize that green solutions may be very expensive, more than infrastructure. This is something that we didn't realize 20 years ago. 20 years ago, we thought that green solution would be cheaper because we didn't realize the maintenance costs of green solutions. And today we realize that sometimes infrastructures may be cheaper and maybe, above all, more effective. So today, what is suggested is that an engineer should have a very objective view, should try to assess to gain a very objective view of the problem and the possible solutions. because the ideal solution is almost always a compromise. It's almost always given by coupling different type of solutions in order to make your storm beach more resilient. Because you know, this is a domain where uncertainty is dominant, and therefore you have to take into account that a certain type of solution may not be effective. If you couple different solutions, you may reach the optimal configuration. And my suggestion for you is don't just have preconceptions like no infrastructures, no green solution. I can see today both of these extremes. I have some colleagues saying green infrastructures are absolutely to avoid, other colleagues saying we have to avoid new dams, new breakwaters, and I think it is extremely important that we try to gain, as I said, an objective assessment. A unique solution doesn't exist, but we need to go over the place to try to understand what's going on, as I said before, and conceive the optimal combination of strategies. And you can read this here, and it's not something that they will ask you at the exam. It's something that you may say at the exam in the first question if you want, but it is just something that it's very important, I think, for you to achieve, to gain a sensitivity on this, on the fact that any situation is a particular situation, an optimal solution doesn't exist, but very often we have a set of possible solutions that may be possible to integrate. These are concepts that you need to make part of your skills, of your abilities. Critical understanding. Okay, here there is a mention to sand bypassing, and what do I mean? Let me just dedicate a couple of minutes to this. It's not really relevant in our coasts. Our, I say in Italy, or let's say, I shouldn't say our, I should say the coast close by here. But in some cases, sand bypassing is indeed an important issue, an important solution. So what is sand bypassing? So let's suppose that you have a coastline like this, and with a river getting into the sea. So this is offshore. And this is land or land. Okay, so you have this river. Okay, water flowing. Okay, what happens here? The river brings sediments, and then the river gets the sediment, the water from the river, the current from the river meets the waves coming from the oceans. So what often happens here is that you have the formation of a significant bar. Here you have a bar, and let's say this bar can be extended over the whole extension of the coastline, but usually here the bar becomes more important. Why it becomes more important? Because you have a huge volume of sediment coming from the river. And therefore, it's not just the sediment that is subjected to run up. There is also an additional contribution of sediment from the river. So here you have a bar that becomes more prominent. And this is a problem for navigation. And therefore, people don't like it usually, because when the river is important, it's important also for the ships to be able to go up the river. And therefore, it is a typical situation where we have important rivers flowing into this ocean or into the sea that they build river walls here to concentrate the river flow, to confine the river flow, It's like an extension of the river into the sea in order to avoid the formation of the bar. What happens then? When you do this, of course, if you remove the bar that previously was formed, the fact that the river flow is concentrated basically avoids a new formation, the formation of a new bar. But the problem is that you block the long-shore sediment transport with the rivers, like you would do with a groin. So what happens is that if you have a direction of propagation of waves like this, what happens is that you have a flow of sediment from the left to the right. And what happens is that you have deposition of sediment here, accretion of the beach here, and erosion here. So this is a problem indeed, because in some cases, and there is a link to a project in Australia, a relevant river bypassing, sand bypassing project. Yeah, I come to your question. There is a link. There are some cases where this erosion caused significant problems.
No, just the red line, the red arrow, is the wave direction or the current direction?
It's the wave direction. I should have depicted here in blue, because here the flow was depicted in blue, so this is the direction of waves. Which is, you know, I'm not talking really, I never talked about currents. Currents is something that usually I don't consider. Okay. But still, you're right, there will be a time when we will talk also about currents, because waves are different from currents, but sediment transport can be caused by waves and currents. And usually I focus on sediment transport by waves, but you are right, it's a good question. But let's say that in this case it's just a direction of waves. And in red I indicated the deposition erosion, new shape of the coastline. So what did people invent to resolve this? They invented a process called sand bypassing. So they bring the sand from here, they take the sand from here and bring the sand here. It can be done manually, but in some cases they brought a bypassing, they devised a bypassing with pipes. So basically there is a pump pumping water from here, water with a lot of sand, because they pump the water very close to the coastline. So there is the fluid is a two-phase fluid, sand plus water, is pumped here, and they restore the original configuration. And this is something that is indeed a beach restoration strategy that in some countries in Italy, I don't know any project of sand bypassing, but in some countries, especially the countries that where important rivers flow into the ocean, and with estuaries, because this is a situation that is typical of estuaries, not of deltas. And I know that in some countries these projects are very popular and very used. So I'm not going into the details because there are some links and it's not really something that is relevant to our basic treatment. But I just wanted to inform you on this also possible solution. I may ask you an example what is sand bypassing, and if you just I will draw a sketch like this, it's fine to me. Okay, now I will stop for 15 minutes and then we meet again with the PC. Okay? If you have any comment on the way I structure my lectures, please, I will propose to you a questionnaire in a couple of weeks, maybe less. But meanwhile, if you have any critical comment, just let me know. If it is too basic, if it becomes too complicated, today was not too complicated, but maybe next time I will go into some math. If it becomes too complicated, too trivial, too basic, whatever, too fast, too slow, or maybe if you see significant overlaps, with Professor Archetti, just let me know. Okay? Okay, as usual, I Leave the room for a coffee.